So these notes are going to be about adding and subtracting polynomials. We actually have already done this a couple of times, but this is just going to be a review of adding and subtracting. There are some vocabulary words that you definitely need to be familiar with, not necessarily memorize, but you definitely need to know what they are. So monomial means one term, so numbers and variables combined through multiplication. So the mono in monomial just means one term. So there's some examples there. Negative 3x to the 8y. These are all being multiplied by each other, so it just looks like one term. Negative 9, that's actually like a negative 1 times 9. So that's one term. 14m, one term. Binomial means two pieces, like a bicycle has two wheels. So binomial means two pieces being combined by addition or subtraction. So two pieces. So we have 4x minus 7. So this is a monomial minus another monomial, which makes a binomial. So there are a couple more examples of that. And then last we have a trinomial. So tri means three, like a tricycle has three wheels. So trinomial just means we have three monomials, again, being combined by either addition or subtraction. All of these are addition, but they could have subtraction there. After trinomial, we just classify all expressions as a polynomial. So poly just means multi pieces or multiple pieces. And so it's a monomial or sum of monomials. We actually could call both of these also a polynomial, but we specifically call a binomial, and trinomial, three pieces of trinomial. Okay, so just jumping in then to some of the examples here, it says find each sum or difference. So you definitely need to know that sum means to add. So hopefully from elementary and middle school, you remember that that means to add, and difference means to subtract. So looking at number 1, we have parentheses, which generally would mean to multiply, but I don't have anything in front of this parentheses or anything in front of this parentheses, so I'm just adding here. Remember, when we add, we can only combine like terms. So things that are alike. In this case, we have 4x, which is like 3x. So 4x plus 3x would give us 7x. And then we have a negative 5, doesn't have a variable, and to that we would add a positive 6. So a negative 5 plus a positive 6 is going to give us plus 1. We cannot combine 7x and 1 because those aren't like terms. 7 has an x, 1 does not. So at this point, we are done with that. So number 2, a little bit different just because now we are subtracting. So when we are subtracting, you could do it a couple of different ways. I definitely am going to suggest that you distribute this minus sign to both of these pieces. Basically, that's like a negative 1 that we want to distribute. The first piece we normally would get right, but students forget that we're also subtracting this 3y squared just because the minus sign is so far away. So I am going to suggest that we distribute this negative, so that would be a minus 4x squared and minus 3y squared. And then in the front, we're still going to have x squared plus y squared. Okay, so now at this point we can just combine like terms. So we have x squared and negative 4x squared, so that's a 1, right? If there's not a coefficient, we know that's an understood 1. 1 minus 4 would give us negative 3x squared. When we add and subtract, we keep the variable and exponent, so x squared stays x squared. And then we have a positive y squared, again that's a 1y squared, minus 3y squareds would result in 1 minus 3 would be negative 2y squared. So these are both squared, but because this one is x and this one is y, they're not like terms. So at this point, that is our final answer. So just a few more examples similar to that. Now we have a trinomial and we're adding another trinomial. Just gets a little bit longer, but the steps are basically the same. So we have 3x squared plus negative 3x squared. Because we're adding, I don't really need to distribute a positive. It doesn't change anything. But if that wasn't a minus, like on number 4 when we get to that, that is really important that we distribute that negative. So 3x squared minus 3x squared, those are actually a zero pair. 3 and negative 3 are opposites. So when we try and add opposite numbers, we are going to get a zero pair. Those would just give us 0. So we're not going to write any x squareds. We could write 0x squared, but generally if it's 0, we don't write it at all. Okay, and then we have negative 5xy squared. So I'm looking over here for xy squared, and again here is another xy squared, so negative 5. So these are not opposites, right? A negative 5 plus another negative 5, those are actually the same. So negative 5 plus negative 5 is going to give us negative 10. And again, when we add and subtract, we keep the same last name, so xy squared. And then our last pieces, we have plus y cubed. So I'm looking for another y cubed term to combine with that, and I have one here at the end. So this is plus, that would be a 1y and minus 1y. So positive 1 plus negative 1. Very similar to the first two terms. They are opposites, so those would give us 0. Opposite terms give us a 0 pair. So our final answer here is just negative 10xy squared. Okay, in the next example, again, we have this minus here in the middle, so I'm going to distribute that minus 1 or negative 1 to every piece inside the parentheses. Essentially, when I distribute a negative, all that does is change every sign. So this 2x squared becomes negative, this negative 8 becomes positive, this positive 2 becomes negative. So every sign changes. So at the front, I'm still going to have all of those same pieces. So I'm just going to go ahead and bring all of those down. So 6x squared plus 12xy plus 4y squared. Then minus 2x squared plus 8xy minus 2y squared. At this point, now I combine like terms. So I have a 6x squared at the front. I'm going to look for any other x squared terms through here. So right here at negative 2x squared, there's another x squared term. And then I keep looking, no more x squared terms. So I'm just going to put 6x squared minus 2x squared. So 6 minus 2 would give us 4x squared. We keep the same variable and exponent. Next pieces, we have a positive 12xy. So I'm looking through here for any other xy's. There we have one. So plus 8xy. So positive 12 plus 8 is going to be plus 20xy. And then the last piece I have here is plus 4y squared. So I'm just looking for other 4y squares, and since this is the only piece I haven't used yet, I would definitely want to just direct my attention there. So minus 2y squared. So 4y squared minus 2y squared is going to be a positive 2y squared. We do put it in this order because we put it in alphabetical order first, and these both have an x, so this x has a higher exponent. We call that a degree. So this x has a higher degree than this x does because that x is 1. So 4x squared goes first, then 20xy, then 2y squared. Because this one doesn't have any x's, it goes at the end. If I had another term that had just a y, that would go after y squared, and then constants actually go at the end. So numbers without variables go at the end. Okay, so number 5, 6, and 7 are just another way to do that same problem. They're different numbers, obviously, but to do the same problem, it's just written vertically. So in elementary school, when you're learning to add and subtract, it's usually written vertically. So this is just another way to line that up. Again, the problem is that students face is that this minus has to go to all 3 of these pieces. So particularly when you get down here to plus 9, you have to remember to go back to the minus negative 10. So again, just like on the previous one, I would distribute that negative before I start. So I'm going to distribute a negative to x squared y squared. So that would be negative x squared y squared. And then negative to negative 9xy would be plus 9xy. And then a negative to a negative 10 would be plus 10. So because I've now distributed this negative to each of those pieces, I'm basically done with that middle row. So I'm just going to mark that out. I don't need that anymore. I've changed my problem to now this. So now I have 7x squared y squared minus x squared y squared. So these are like terms, which is why it's nice to have them lined up. So this is 7 minus, again, that's an not imaginary, an understood 1. So an understood 1 right there. So 7 minus 1 would be 6x squared y squared. Then we have negative 8xy plus 9xy. So negative 8 plus 9, again, they're like terms, is going to be plus 1xy. And you don't have to write a 1. Remember, if there's no 1, it's understood. Just like right here, you don't have to have that 1. And then the last pieces, these are the constants. So positive 9 plus 10 is going to be positive 19 or plus 19. So 6x squared y squared plus 1xy, or just plus xy, plus 19. Okay. Number 6, so just going to follow the same process there. I would start by distributing this negative. So that would be negative 2x squared, then plus 8xy, then minus 4. I'm done with that middle row, so I'm going to mark it out because I distributed the negative. I don't really need that anymore. So now this is my problem. My question, 5x squared minus 2x squared is going to give me 3x squared. Then 3xy plus 8xy is going to be plus 11xy. And then I don't have anything here, so basically that's like 0 minus 4, or I can now just bring this down. If I had not distributed that negative, it is very frequent that right here students would bring down a plus 4. But because I distributed the negative in the front, at the first part, then now I recognize that that's actually a negative 4, so that's going to be minus 4. All right, and number 7, exact same thing. So I'm going to distribute the negative first, then just simplify after that. So a negative to an x squared is negative x squared. Negative to 2xy is minus 2xy. Negative to a negative y squared is plus y squared. So again, we're done with that middle row. So I'm going to just mark that out. I don't need this anymore. And now I'm just simplifying from here. So x squared minus x squared, this is like 1 minus 1. Again, they're opposites. 1 and negative 1 are opposites. So those are going to actually give us 0. They're a 0 pair. Then we have 2xy minus 2xy. So again, I have positive 2, negative 2. These are opposites. So opposites give me a 0 pair. And then the last piece, we have y squared plus y squared. So these are not opposites. I have a positive 1 and another positive 1. So positive 1 plus 1 more is going to be 2y squared. So just a quick review there of addition and subtraction. There are some word problems here that you definitely could take a look at. I'm going to do a couple of these over here just to make sure we understand how we could apply then this addition and subtraction. So number 12, we have a triangle. It doesn't tell us what kind of triangle, so we can just really draw any kind of triangle that we'd like. It tells us that we have lengths of x plus 5, x minus 2, and 2x minus 4. So I'm just going to write each of those on one of the sides. It doesn't really matter which one is what because they didn't specify. So x plus 5, x minus 2, 2x minus 4. The question is, or the problem is, find the perimeter of the triangle. So hopefully you remember that perimeter is we add up all the sides. Definitely need to know that. That is not on a formula chart in high school anymore. So perimeter, add up all the sides. So for me to add these 3 pieces together, I'm just essentially adding like terms. So some students might write this out. They would say P equals x plus 5 plus x minus 2 plus 2x minus 4. You can do that if you would like, and then you identify the like terms. I particularly think it's easier just from the picture. So I have two x's here, an x here, and an x here. So these are 1 and 1. So 2 plus 1 more here makes 3, plus 1 more here makes 4x, which is exactly what I would get here if I just added these x's together. And then we have constants. Again, constants are numbers without variables of a positive 5, a negative 2, and a negative 4. So 5 minus 2 would be 3, and 3 minus 4 more would be minus 1. Again, what I would get if I just, from here, did 5 minus 2 minus 4. So a couple of different options there for you to look at. I would definitely suggest the picture, but if this is works for you, then you can do that as well. All right, number 13, we have find the perimeter of a pentagon that has 3 sides of length 2x plus 3 and 2 sides of length x minus 1. There are a few different ways, but right now if we're just adding and subtracting, I would draw a pentagon. So a pentagon has 5 sides. They kind of told me that because they said I have 3 sides that are 2x plus 3. So I would label the 3 sides that are the same, 2x plus 3, 2x plus 3, 2x plus 3. And then I have 2 sides that are x minus 1. So the other two, x minus 1. Same problem, find the perimeter. So perimeter, we're adding up all 5 sides. When we add, we put all the like terms together. So my like terms are going to be 2x, 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 another 1x, and one more 1x. So this would be 2, 4, 6, 7, 8x. If you wanted to write this out as an expression, it would look very similar to this. It's going to be really long because you're going to have 5 pieces there. So 8x. I still would recommend using the picture instead. And then we have constants of 3, 3, 3, negative 1, and negative 1. So putting all those together, 3, 6, 9, minus 1 would be 8, minus 1 more would be 7. So plus 7. You could just take 2x plus 3 and multiply it times 3, and you would use distribution to do that, but we haven't done that in a while. So if you could do that, I would definitely recommend it. I think that's much faster. So 3 times 2x plus 3, right? We have 3 sides of this, plus then we had 2 sides of x minus 1. So 2 times x minus 1. So if you remember how to distribute, you could just simplify that as well. We're going to cover that tomorrow. So in case you don't remember, I would definitely pay attention tomorrow. Okay, number 14, one rectangle has an area of this expression right here. Second rectangle has an area of this. How many more square feet is the first rectangle? So how many more you should have learned in elementary school, then that means to subtract. So we're going to take the first rectangle's area minus the second rectangle's area. So if I were writing that out as an expression, I would write 7x squared minus 4x plus 12, and then we're subtracting all of the second area, so we have to put that in parentheses. If I don't put that in parentheses, then I'm not going to subtract all of it. I would end up just subtracting the 4x squared. So if this parentheses is not here, then it looks like just minus this, not this and this as well. So I'm going to distribute my negative. So this would be negative 4x squared. Distribute the negative to 2x, that would be minus 2x. Distribute the negative to a negative 1 becomes plus 1. So now we're just combining like terms again. So we have 7x squared minus 4x squared. It's going to give us 3x squared. And then we have x terms, so negative 4x minus 2x is negative 6x. And then last pieces, the constants, we have 12 plus 1, which is positive 13. So the first rectangle is this much larger. The area is this much larger than the second one. And we would add feet squared on that, just for our units. Okay, last one, number 15 that we'll do, we have subtract 3x minus 6 from 24x plus 18. So we are subtracting this first one from this one. So this is going to go first, then we're subtracting that. So really important that you write that correctly. So I would subtract 3x minus 6 from this one. So I don't need this anymore because I wrote it down here. One more time, I have a negative here. I would distribute that negative, so that would be negative 3x. Distribute that negative, that would be positive 6. Combine your like terms, so 24x minus 3x would be 21x. And then positive 18 plus 6 would be positive 24. So this is the expression that I get. So hopefully that just is a quick review of adding and subtracting for you. It should not be sound unfamiliar. It should be definitely familiar to you. So come in for when if you have any questions.